and iOS backup files 28th, device hardening like router security, like how to secure a router and switch both. And 29th, the last day, wireless concept, introduction to wireless and how wireless works, how many types of wireless. Then we'll end our training program. These are our plans. It's clear? The last day, I'll try to share some documents which is helpful for your personal studies and for certification. Yeah. Is it okay for everyone?
Yes.
Aishwarya,
Yes.
Bhargav, Fahim,
Yes, sir.
Jnanaranjan, Jaideep,
Yes, sir.
Joseph.
Yes, sir. Yes, sir.
Hi Naresh, morning.
Yes. Yeah, morning.
Yeah. Pramod, Pranav, Ratnakar, Sam, Sumant, Teja, Nagaraj, Jail. Yeah, good.
Yes, sir.
Okay. So try to understand today's scenario is, see all end devices, PC1, 2, 3, these end devices are connected to switch. Switch to router, router to ISP, ISP internet. This is our regular setup actually, common setup, internet connectivity. Correct guys? Yeah. In internet is all public servers are connected to internet. Example, gmail.com, yahoo.com, fb.com. Like all millions of websites are connected to internet. And if you want to reach the internet, we require a service provider must. And to enable communication between two or more different networks, router is must. And to connect multiple computers to centralized switch is required. This is a basic network setup. Agree? And for this router 1, there are two interfaces connected actually. Fast Ethernet 00, serial 00. Tell me routing table of this router, R1 router routing table. There are two interfaces are up. Even serial 0/0 is up. Now 10.0.0.0 is directly connected to fast Ethernet 0/0. 202.1.0.0 is also directly connected 202.1.18.0.0. Sorry, it is classy, right? 202.1.0.18. I'm directly writing IP address. Serial 0/0. Two networks. There are two interfaces, two networks in routing. What is the fundamental rule? Router LAN interface IP address. LAN users IP address must be in same network. So for PC1, 10.2 have assigned. For PC2, 10.3, 10.4. Now let's understand the scenario. Scenario is PC1 trying to connect with PC3. I repeat, PC1 trying to connect with PC3. Tell me source IP and destination IP.
2 is the source IP, and 10.4 is the
Yes.
destination.
10.2 is the source IP, 10.4 is destination IP. Now in IP packet, source IP address, destination IP address, both are in same network or in different network.
Same network?
Same network, then packet will go to switch and switch will forward it. So we know how same network communication is happening. But that is not my scenario. My scenario is PC1 is trying to connect with gmail.com. He's trying to open Gmail website. Now tell me source IP address and destination IP address. Source IP is no, 10.2 is a source IP. And what will be the destination IP address? Yes, please. What will be the destination IP address? Destination website name is gmail.com. But my question is destination IP address.
If you ping the website, it will give you the IP address, right?
To know IP address, that is a process. But initially, packet has to generate, right?
Yeah.
That is what I'm asking. So, do you know Gmail IP address? No,
No.
we don't know. You know Yahoo IP address? Facebook IP address? WebEx IP address? Zoomgroup.com IP address? Like how many websites in the internet? Millions of websites. We don't know any IP address. We know the the site, I mean names we know, right? So entire internet is unknown. You can say unknown destination actually. We don't know any one of the IP address. Let's take one example. If you know IP address of gmail.com, actually in the first case we don't know, but just for example, if you know IP address of destination, which is your Gmail, it is 8.18.1.1.1. Now tell me, what is the destination IP address?
18.1.1.1.
Packet generated. Source IP is 10.2. Destination is 18. Different network. If different network, packet come to which device? Router. Now what router will do?
Packet switch.
Router every time. Come on. Almost we are going to ending our sessions actually. Yeah? Router function is what? Router will forward the traffic or drop the traffic based upon the routing table information. Router will check the routing table first. Agree? So router will check the routing table whether destination information is available or not. If it available, then packet switching, packet forwarding. If it is not available, then simply drops it. See here, a destination is 18.1.1, but what networks are available in routing table? 10. Network, 202. Network. 18 is not available. Then what router will do? Drop. Traffic is dropped. Then how user can reach gmail.com? So gmail.com website IP address must be available in routing table. Then only can be reachable. So that destination I'm going to update here. 18.1.1.1. Actually, destination is unknown. This is the first case. In second case, if we know that IP address, where we need to update? In routing table. Correct. Now, PC1, PC2, PC3, all our LAN users can only reach which website? Gmail. Because Gmail IP address we added here actually. Okay. Now the same PC1 user want to open yahoo.com. In first case, Yahoo IP address is what? Unknown. In second case, if we know Yahoo IP address, let's say it's a 19.1.1.1, then destination IP address is 19.1.1.1. Packet comes to router. What router will do?
Checks routing table.
Checks routing table. But in routing table, 10. Network, 202. Network, 18. Network is available. What about 19. Network? If it is not available, then what router will do?
Drop.
Drop it. So means users can reach yahoo.com? No. Then when users can reach yahoo.com? This 19. Network need to update in routing table. Actually, 19. Network is unknown. We don't know. In second case, if we know, we are adding. That's all, right? Okay. Now all my LAN users can reach website. Which websites only? Gmail,
Gmail.
and yeah. Like, what about PC1 want to communicate with Facebook.com? In first case, what? IP address unknown. In second case,
Yeah,
if you know, we need to update where?
voting.
Routing table. Similarly, how many websites in internet? How many websites in internet?
Millions of websites.
Millions of websites.
So means millions of websites IP address in first case we should know. And second case, what we need to do?
We need to add them to routing table.
We need to update a routing table. Is it really possible, Aishwarya?
Not.
No. Then how we are reaching internet, man, now? You just open the web browser and you can type any websites you can reachable if you have internet access. Yes or no? Yes, we are reaching. Then how? So as per router logic, as per routing mechanism, router always will check routing table whether destination is available or not. There is no compromise in router action. It will check destination IP address, not available, drop it. That's all. But how we are reaching now? Tell me. Yeah. Ultimately, router should maintain all websites information. I mean, all destination information should maintain actually. But practically it is not possible. See, in my routing table, I have 10.0.0.0 network. Network is available in routing table. It means under this 10.0.0 network, how many IP addresses will come?
So, and 255 to
How many IP addresses? Sorry.
255.
Yeah, no. 10.0.0.0. This is the network ID. Under this network, how many IP addresses will come?
Uh, 10.255.255.255. Is that correct?
Just 1 minute. I'll come back. Just 1 minute. Yeah. Did you got answer for this? How many IP address comes under this 10 dot network? 16,777,214 IP addresses. Agree? Because 10.1 will come under 10.2 also, 10.3 also, up to 10.255, 255, 255. These all IPs comes under 10 dot network. So if my routing table having 10 dot network, it means my routing table maintains how many IP addresses? 16,777,214 IP addresses. Like 172.16.0.0. Under this network, how many IP addresses will come?
And see.
How many?
Is it 65,000?
Correct, 65,534. Like what about 192.168.1.0 network? Under this network, how many IP addresses?
254.
254. Like total, how many IPv4 addresses? And an entire IPv4, total how many IPv4 addresses? 4.3 billion. Like all 4.3 billion IP addresses comes under one ID we call global ID. Remember? 0.0.0.0. Under these IP address, how many IP addresses will come? I mean, under this global ID, how many IP addresses? 4.3 billion. So in routing table, you just update a global ID, which is 0.0.0.0. Now my router 1 is maintaining how many IP addresses? Yes, please, everyone. How many IP addresses?
3.
3. I'm asking about this. If you update global ID 000, then under this network, how many IP addresses will come?
4.3 billion.
4.3 billion IP addresses are available in routing table right now.
Okay.
So now user can reach any destination. It can be Gmail, it can be Yahoo, it can be Facebook, it can be any destination. My routing table is maintained. Now router will drop the traffic or will forward it.
Forward.
Yes. Now we can reach any destination. So this type of routing we call what? Default routing. So default routing is used to configure to access internet, to reach any destination, to reach unknown destination. Generally can configure for network internet access. If you configure default routing, then router should not drop the traffic. It has to be forwarded at any cost. So default routing, is it optional configuration for internet access or is it mandatory configuration for internet access?
It is mandatory.
It's mandatory. So remember guys, every internet router must be configured default routing. Without default routing, we cannot access internet. We cannot reach unknown destination. You want to reach yahoo.com, your router should maintain default routing. Like want to reach any websites, millions of web destinations, your router must maintain default routing. So home routers, which are using for home internet, like Wi-Fi routers, is pre-configured with default routing, whereas Cisco routers for commercial network, for corporate networks, we need to configure default routing action. Got it? Can read this point. A default route, or we can call gateway of last resort. What is the purpose of default routing? Allows traffic to be forwarded. Router should be forwarded actually. It should not be drop the traffic. Even without any specific route to the particular network. Do you have any particular network to reach a gmail.com? Do you have any particular network to reach yahoo.com? No, but it has to be forwarded using a global ID. We call default routing. So default routing is identified by all zeros in both network and subnet mask. Like default routing is like a static routing. We can call static default routing also. What is the syntax of static routing? IP route, destination network ID, destination subnet mask. So destination network ID is 000. Destination subnet mask is 000. So it means any network that can be in any subnet, traffic should be forwarded. So it is generally configured for accessing internet where destination is unknown and it is the least preferred route in the routing table. So default routing is a least preferred action. This is the configuration part. IP route, destination network ID plays 0.0.0. Destination subnet mask plays 0.0.0. Exit interface, your WAN link, and port number 00. Like we can configure this actually. Okay. Any doubts on default routing? Say, on this router, config mode, IP route 0.0.0, 0.0.0, serial 0/0. Any network, any subnet mask. Done. This is default routing configuration. Yeah. Now if we check routing table, static routing. What is the code of static routing? Routing codes. Remember, static routes will shows what? Yes. For RIP, R. OSP of
O.
O. Default routing is also static default routing. It's also S, but that's with a star. It is a default actually. Only S, static. R is RIP. O is OSP. D is EAGRP because EAGRP is a dual algorithm. So it's a D actually. If you see D network means EAGRP networks. O networks means OSPF networks. S with star, asterisk, it is default. Now, if we check show IP route, the routing table, it's in the last line. This is default routing. Okay. It's clear, everyone? All good. So next scenario, try to understand next case. All LAN users to reach internet, what routing must be configured in routing table?
Default routing.
Excellent. So have configured default routing. It is updated in routing table. Now all LAN users can reach internet after default routing is configured. Can reach or not?
Yes.
Yes. Now, let's understand how the reaching is. Now PC1, PC2, PC3, all computers are connected in LAN, local network. All websites, your Gmail, Yahoo, Facebook, all websites are connected in internet. So internet is, let's say, private network or is it public network? Internet is.
Public.
It's a public network.
Public
What
network.
about your computers, PC1, PC2, PC3 are all LAN devices? Is it private network or private public network?
Private network.
They are in connected to private network. Even in IPv4 address also we have two categories, private IP address, private public IP address. Way to use public IP address? To reach public network. Way to use private IP address? To reach private network. Agree?
Yes.
Yeah. So PC1, first user is trying to reach Gmail, one of the website internet. Tell me what is source IP address? Source IP address. PC1 is trying to reach public network. Source IP, please.
10.2. 10.
10.2.
Yeah.
10.2, is it private IP or public IP?
Private.
Private IP. So source is private IP. Destination IP. What is the destination IP? The
Public.
PC1 is reaching with one of the websites in internet means public IP, right? It's trying to reach to public network. Now packet generated, it comes to router. Again, there is a problem. What is the problem? Router will say, user, you are reaching public network using which IP address? Private IP address. Source is private, destination is public. How it can be reachable? No, I will not allow you because you are reaching your destination is public network, but you are from private network. No, I will not forward you. I'll drop it. Actually. How it can be possible? Are you getting my logic? So using private IP, you can reach private network. Using public IP, you can reach public network. But now what happening here? A PC1 is private IP, but your destination is what? Public. So it's not possible. Your router is dropping the traffic. Getting my point? Everyone. Naresh,
Yes, yes.
Sam.
Yes.
Yeah. So then how users can reach internet?
ISP will provide a public address to the.
Right. So we need to assign public IP address, right? Okay. Say for PC1, if I assign public IP, let's say 90.2, 90 network is public network. Okay, I have assigned public IP for PC1. Now what is source IP address? Same scenario. PC1 want to reach internet. Now
19
PC1 I have assigned a public IP. So source IP is what?
Public.
90.2.
90 dot. Is public or private?
Public.
Public. Destination is
Also public.
Now PC1 user can reach internet?
Yes.
Yes.
Yes. The source is public, destination is also public. Okay. But point is, now PC1 is it private computer or it public computer?
Public.
Public computer, because you assign public IP address. Then who will use this computer? Who can access this computer? All public users can access. Now it is a public. So all public traffic will come to PC1, will coming to the LAN, remaining all PCs also can be impacted. So attacks will come easily actually. So not recommended to use public IP in the LAN.
To the router.
Yes. So to provide security, we must use what?
Firewall.
For LAN, we must use private IP address for security purpose. Agree? If we use private IP in the LAN, then your network is secure. But can you reach internet?
No.
No. If we use public IP, I can reach internet, but not safe, not secure. Got it? I'll give one general example. Naresh? Sumant? Hear me?
Yeah, I can hear you.
Let's say Naresh know only Hindi language. Sumant knows only English language. Then how both can communicate?
You translate.
We need somebody to translate in between.
Yeah, what translator will do? It translate
English to Hindi and Hindi to
English
English.
to Hindi, Hindi to English. So means Naresh don't require to know English. Sumant not required to know Hindi. So we have a translator. So Naresh will speak in Hindi only, but they can communicate with Suman. Suman will speak in English only. They can communicate with Hindi also. Translator is doing, right? Similarly, we need to configure one mechanism called translation mechanism in router. So that translation mechanism we called NAT, network address translation. Here, a network address should be translate. What should be translate? Your private traffic, we must use private IP address in LAN for security purpose. But still we need to communicate the public network. Then what we required? Translation mechanism. So NAT is going to be changing one IP into another IP. So NAT will take care about it. NAT will translate the private traffic to public, public traffic to private. Now no need to be used public IP here actually. So your private users to reach internet, NAT, is it mandatory configuration or is optional configuration? Mandatory. So every internet router must be configured default routing and NATing. Because of these both configurations, we are reaching public network and unknown destinations. Using private IP, you're reaching internet. Just open your command prompts, everyone, and check your IP address. See, my IP address is 192.168. 192.168 is it private IP or public IP?
Private.
But I'm connected to public network. I'm in the WebEx. How it possible?
Translate.
NAT is configured in my router, and I can reach any websites from my computer. So how it can be possible? Default routing. Got it? Yeah. So LAN users to reach internet, what are the mandatory configurations?
Default routing and NAT.
Yeah. NAT, network address translation. NAT is a process of changing one IP into another. It is used to save precious public IP addresses. NAT is usually used to translate private IP to public IP address and vice versa, like public to private. It provides security. Yes. So using private IP itself, we are reaching public network securely because of NAT. Agree? If NAT is not developed, then we must use public IP. If we use public IP, everyone come into public computers. Clear? Any doubts?
The broadband routers that we get at home, are they doing NAT by default?
Yes. Every default, every internet router, it is a home, your Wi-Fi router or your corporate routers or organization routers. If the device forwarding traffic to internet means that device must be configured default routing and NATing. Even your home-based routers also is pre-configured everything actually. If you have access to login, if you try to log in and then check it out, you can get this default routing and NAT. It's enabled. At anywhere, if you take a corporate router, corporate network, your devices are connected to switch, switch is connected to router, router connected to firewall, firewall to ISP. So firewall, router, switch, anywhere NAT or default routing must be configured actually. Either some topologies will enable NAT on switches or NAT on routers or NAT on firewalls. But any device, this must be configured. But where you configure it depends upon your design, network design. Mostly we configure default routing and NATing in routers. But default routing must be configured in routers. NAT we can configure on firewall also, because firewall we can write the rules, inbound, outbound rules. If you don't have a firewall, then router. Clear?
Hello, sir. I have a small doubt.
Yeah, Pramod, tell me.
Sir, internet it access global ID. In our office premises, they will accept only limited IP address, no, sir, for security purpose.
That is what again you write the rules, conditions you applied. So global ID is configured, means LAN users have access for any website, right?
Yes.
Then policies will come in the picture. Now they write the policies. Which traffic need to be allowed, which traffic need to be denied. That policies will write in the firewall. So you are limited now.
Yeah.
Okay.
Yeah. Okay, sir.
So types of NATs, understand what type of NATs we have. Static NAT. What is NAT? You know what is NAT? NAT is the process of changing one IP into another IP. NAT function is it will change, it will translate one IP into another IP. Static means manually, fixed. So that manually we need to map which private IP need to be translated to which public IP. That we need to translate actually. Okay. Like PC1. What is PC1 computer IP address? 10.0.0.2. So 10.2 user, this private IP address is going to map with, we need to purchase one public IP in ISP, and you need to map to the 16, let's say 16 IP address I purchase. 16.1.1.1. Right. And these IPs are fixed. Manually we are mapping. So 10.2 user always can reach internet with 16. Now understand, whenever 10.2 is reaching internet, what is source IP address? 10.2. What is destination IP address? Some public IP address. Packet generated. When it comes to router will say, no, you are reaching public network using 10.2, which is private IP, it cannot be forwarded. Then what NAT will say, no, router, you don't drop it. So I will take care about to forward it. I'm going to translate it. Like which user is trying to reach internet now? 10.2. So 10.2 is in NAT list. NAT is going to translate to which IP address? 16. So means your source IP is now changed. NAT is going to change your source IP. So a source IP is not 10.2. A source IP address is 16.1.1.1. It is translating. Destination is same your Gmail public IP. Now what is source IP? Public IP. Destination IP? Public IP. Traffic has been forwarded. But what you need to understand here, 10.2 IP address always can reach internet with 16.1.1.1. That IP is fixed for 10.2. But point is, what about 10.3 user? How 10.3 user can reach internet? The IP which you purchased from service provider, which is 16.1.1.1, that is mapped to 10.2. That cannot be used for 10.3 actually. When if you use static type of NAT, because static NAT works like a 1:1 ratio method. So for 10.3 user to reach internet, again we need to purchase one more public IP address. Let's say I have purchased 17.1.1.1. And that manually I'm mapping, and the IPs are what? Fixed. So 10.3 user always can reach internet with which IP address? 10.3 user always can reach internet with which IP address? Which public IP address? 17.1.1.1. What about 10.4 user? How 10.4 user can reach internet? We purchased two IP addresses right now. One 16 and one more is 17. So 16 is fixed for 10.2, 17 is fixed for 10.3. What about 10.4? Yes, we need to purchase one more public IP, 18.1.1.1. It is fixed. Like what if I have 100 users in my network? Then how many public IP addresses we need to purchase? 100. Okay.
What's the secret?
Yes. Got. So now 1,000 users, then so do you recommend to use static NAT in real networks?
No.
No, because static NAT works 1:1 ratio. Let's see the next type of NAT, which is dynamic NAT. Which is the best, static NAT or dynamic NAT? Which one is the best, man?
For user traffic, dynamic would be better
Why?
because more number of users will try to access the internet.
No. See, even dynamic NAT also works like a static NAT. Dynamic NAT also 1:1 ratio method actually. Then what was the differences between static NAT and dynamic NAT? Is in static NAT, let's say you purchased 3 public IP addresses from service provider, 16.1.1.1, 17.1.1.1 and 18.1.1.1. How many public IPs we purchased? 3 public IP addresses. So 16 IP address, which private user you want to mapping? 10.2 or 10.3, 10.4? That's something we need to decide and configure in the same as is in router. So you have to decide, you have to make a decision. Oh, 16.1.1 IP address I dedicatedly use for 10.0.0.2 user. That's something we are going to configure manually. And remaining two more public IPs are there. So for 17.1.1 IP address, we want to use for which private user IP address? That's something we need to decide actually first. And you configure manually. So I have decided to use 17 for 10.3 user, 18 for 10.4 user. So we are configuring manually mapping in static NAT. Then 16 or 10.2 fixed, they're mapped. So 10.2 user always can reach 16. Like 10.4 user always can reach with 18. But in dynamic NAT, you just pull off public IP address, you configure in router. I have 3 public IP addresses. My 3 public IPs are available here. You just dump it. That's all. Now 10.2 user is reaching internet. Source is 10.2. Destination is public. When packet will come, if you configure dynamic NAT, what dynamic NAT will check? Oh, there are 3 public IPs are available. From out of 3 public IP address, 10.2 user can choose anyone. Randomly it can pick, automatically can pick. It can be 16, it can be 17, it can be 18, can reach internet. No need to map manually. Dynamic NAT will provide out of 3 randomly. It can pick any one. It can be 16 sometime, it can be 18 sometime, it can be 17 sometime. Let's say 10.2 is used with 17 and reaching internet. 10.3 using 18 and reaching internet. 10.4 can use 16 and can reach internet. After some time that IP can be changed. So automatic mapping. But ultimately, if you have 100 private users, how many public IPs are required? 100 public IP addresses. Only advantage is in static routing, in static NAT, manually we need to decide and mapping. In dynamic NAT, automatic is mapping actually. So tell me now, which one is the best? Static or dynamic?
So both are same. It's just giving the flexibility to configure.
That's all. Both are same. Do you recommend any one? No. This flexibility is more than dynamic. That's all. Correct?
Yeah.
Yeah. So we have one more type of NAT, which is in real time. We call it as PAT. Port address translation. PAT. Port numbers, port address translation. So how PAT works is 10.2 user will reach internet with 16 IP address. 10.3 user can reach internet with 16 IP address. 10.4 user can reach internet with 16.IP address. So many private users can reach internet with the help of only one public IP address. That can be possible. Mechanism called what? PAT. PAT is also one type of NAT actually. Port address translation. So if you have 100 private users in your network, then how many public IP addresses we need to purchase?
One.
One is enough. You have 1,000 users, like 9,000 private users in your network. It is a university, like one university, like different departments, different sections, different floors, examination cell, like engineering departments, like medical department, art department, many. So thousands of users are available. How many public IPs are required? One is enough. There is one multinational hospital near different floors. There is a 5-star hotel, like different floors. Now thousands of customers are there. How many public IPs are enough? Any? One. How? Bad. So 1-to-1 static NAT. In some cases, we use static NAT, like you're hosting a servers to public. You're hosting a server to public network, then we need to map with server and internet. So in this case only, we require static NAT. We use a static NAT. Mostly PAT, no more dynamic NAT action. So types of NAT, static NAT, 1-to-1 mapping, PAT, many-to-one mapping. Clear? Any doubts? static NAT, one private IP address is mapped to one public IP address, generally used for hosting public servers, internet to server, configured for inbound, incoming traffic. Static NAT configuration. Before static NAT configuration or dynamic NAT configuration or PAT configuration, it can be any, can be any type of NAT you want to configure in router. You want to configure static NAT or dynamic NAT or PAT. So first thing is we need to define NAT on interfaces. Like example, in R1, how many interfaces are there in R1? 2 interfaces. Fast Ethernet, serial. Out of 2 interfaces, on which interface private traffic will generate? On which interface public traffic will go? Where private traffic will come and where public traffic will go? On which interface private traffic? On which interface public traffic?
Private
Fast
traffic
Ethernet
is-
is
Yeah, okay.
Fast Ethernet port is
private.
Traffic.
private because fast Ethernet is connected to private network towards your switch. Okay. And where public traffic?
Serial interface.
Serial interface because serial interface is connected towards to ISP. As a user, you know that. But how NAT can understand where private traffic is generated, where public traffic is generated, because it has to be translate private to public and public to private. On which interface private traffic, on which interface traffic, how NAT knows about it actually. If NAT don't know about it, then you cannot reach internet. Even simply if you configure static NAT or dynamic NAT or PAT and default routing, both you configured, you don't get internet access actually. Because we need to define on router on which interface private traffic and which interface public traffic. We tell to NAT. It's very simple, but mandatory, must be configured. Interface Fast Ethernet 0/0 IP NAT inside commander. Now your NAT can understand. Oh, under Fast Ethernet command is inside means Fast Ethernet traffic is what? Private traffic because inside. Similarly, interface serial 0/0 IP NAT outside command. IP NAT outside. Now NAT understand on serial port traffic is out, public traffic. So IP NAT inside outside commands are optional or mandatory?
Mandatory.
Mandatory must be configured. Then NAT comes to know on fast Ethernet is a private traffic, on serial port is a public traffic. Then NAT will check what type of method NAT is configured, static NAT or dynamic NAT or static NAT, PAT, what type of NAT you configured. Based on that, it will translate the traffic action. Are you following everyone? What are the mandatory configurations for internet access now? First one is default routing. Next, inside outside commands. Next, any type of NAT, static NAT or dynamic NAT or PAT. You forget about dynamic NAT, we don't use it actually. Either static NAT for server to internet or mostly we use what? PAT. Clear? Like how can define it? You can see interface fast Ethernet 0/0 IP NAT inside or outside? What?
Inside.
Inside. Interface serial 0/0. IP NAT inside or outside?
Outside.
Outside. So after NAT inside outside commands, now we can start configuring any type of NAT. If you want to implement static NAT, you can configure. So this is a commands to defining NAT on interfaces. Then this is a configuration for static NAT. IP NAT inside source static. IP NAT inside source static. Manually we are mapping. So 10.2 user, you reach internet always with 16.1.1.1. We mapped. Then 10.2, 16 is fixed. Similarly, 10.3 user, you reach always internet with 17 and IPs are fixed. Like we need to map manually one by one. 10.4 with 18. So like this, static networks. Okay. Next. PAT, port address translation, PAT overloading. Many private IP addresses are mapped to one public IP address. Many private IP addresses can reach internet with one public IP. How many? Many means how many? 10, 20, 200, 2000, 20,000? How many? $60,000 private users traffic can reach internet with one public IP. Okay. Yeah. Configured for outbound traffic. LAN users to internet. LAN means in local network there can be a 200 users, or there can be a 65,000 users, or there can be 16 million users, can be reached internet. All users can access internet at the same time. All LAN users can reach. Like you have Wi-Fi router, right? You have internet at home. You might be connected to 5 members or 4 or 5 members you are in at home. So every person can reach internet at the same time or one by one? No, you don't use. I'm using now. After you stop the second one person. Is it like that? No. All users can reach internet, right? At the same time because of PAT. And based upon the point number 3, we can understand one more point here. Tell me what is that? Based upon point number 3, we can understand one more important point actually. A technical point we can understand. That is also mandatory configuration actually. Try to guess it. All users means what? 10.2 user can reach internet? Yes. 10.3, 10.4, 10.5, 10.6. What is the meaning of all users? .0.0.0.0 network. Agree guys? All users means entire network. Network ID. Can access. Can access means is it a permit rule or is it deny rule?
Permit.
Permit. Permit for what? Permit for what? Permit for internet. Internet means any limited services or all services?
All services.
All services. So all services are can be permitted. It means it's ACL rule. What type of ACL? All rules are permitted. Is it standard ACL or extended ACL?
Standard.
Standard, excellent. So standard ACL rule also need to be configured in router to access internet. We need to permit them all users actually. Now let me make some list. What configurations must be configured on router to reach internet? What is the first thing? What configurations must be configured on router for internet access? Default routing. Next. NAT on interfaces means inside outside command. Agree? Next PAT, port address translation. Next is what? ACL. These are all mandatory configurations, guys. Now, if you take ISP link and connect it to your router, where you configure all the things, then your LAN users will reach internet. So, any brand new router is a corporate router. You got internet link from ISP. It is connected to your router and routed to switch, and switch to end users are connected. But on end devices, internet is not accessing. Internet is not getting. Then what configurations we need to check? These configurations are missing or not if you want to check it. If any one configuration is missing, then you cannot reach internet. Then one by one, you configure enable default routing, not on interfaces, and PAT you configured, and write the permit rule for all users. Then Pakka you'll get internet action. Clear? Yeah. So this is PAT configuration part.
Sir, can you explain the last line?
IPNAT inside source list 10 means ACL rule. Whatever ACL you configured, that we are defining actually. On which interface you are internet cable is connected, and so on, so on interface. The loss is overload. We are telling to serial 0/0, your traffic should be overload. Then many users traffic can be forwarded. If you don't define overload command, then serial interface also can be forwarded one private traffic to one public IP. Similar like a static. Once if you define overload, then many users traffic can be forwarded. So here 10 is ACL number what we have defined. Got it?
Yes.
So as per our plans, we're done with default routing, NAT, PAT. Let's see about remote login protocols. Let me take one picture, then I can understand easily. So between two sites, branch 1 and branch 2. Branch office 1 and branch office 2, they are directly connected actually. This is user 1, user 2, user 3. Fundamental rule, router IP is 1.1, PC's IP address is 1.2 have configured. 1.3, 1.4 are in the same network. So scenario is how this user can log into router. Tell me the process, tell me the ways, how many ways we have. How this user from my user computer, how I can log into router. Yes, please. In packet tracer, you're accessing, okay, directly click on router, but in real time, how you access your router?
Telnet,
You're a network engineer, suppose.
telnet we
Yeah,
used to.
telnet. So what we'll do is just open the command prompt and you can do what? Telnet. Telnet with your router IP, 192.168, whatever your router IP, you can telnet. See, this is my D-Link router login, where I'm connected to Wi-Fi. It's asking the password, credentials, admin. Password is password. I logged in actually. Right? Just simple. Yes, just open the command prompt and telnet with the router IP. Okay. But how to enable telnet functionality? So in this router, telnet should be enabled. We know that how to enable telnet, right? How to enable telnet? Line VTY 024 password. You just create VTY passwords. CCNA login. That's all. Telnet is enabled. VTY configuration. So line VTY configurations is done. Telnet is enabled in branch 1. Then from 1.4 user can log into branch 1 router. Yes or no?
Yeah, yeah.
Yeah. Okay.
So one
So
one
tell me
question. One
yeah,
question.
please.
Which password will take? Will it take the telnet password, or there is one global password we have set, right? Which
No,
pass
telnet password.
only
If you do
telnet?
telnet, you'll ask the telnet password.
Okay.
If access with the console port, it lost the console password.
Okay. So both are
From-
different.
Both are different. See, from your PC, what we can do, take one console cable and connect to router console port directly. If you are in local, your nearby router, this is your laptop, connect it to console cable and open the putty software and access it with serial port. It will ask the password. That password is console password. But what you are doing, you are in local network. Means you are in first floor, but router connected in 7th floor. Or you are in home, router is in customer location remotely. Then what we can do, just open the command prompt and telnet your router IP. It will ask the password. That password is telnet password. Okay.
Got it.
So from 1.4, I opened command prompt. I'm doing telnet to router IPs 192.168.1.1. It will ask what? It will ask password. So what is the password we configured? CCNA. Entered password is CCNA. Now we'll get what? We'll get router 1 greater than symbol, which is user mode. If type enable, again we'll ask the enable password or enable secret. This is a Cisco. Now we can come to which mode? Router 1 privilege mode. In privilege mode, you can enter your all verification command like show run command, show IP routing table, all show commands you executed. But what we need to understand here is all traffic where it is generated actually. Please reply to my questions. This all traffic where it is generated, from which PC we are accessing. Well, if you're following me, guys, I'm doing this all the activity telnet from which PC in our example? From 1.4 PC. 1.4 PC is a source, means traffic is generated from 1.PC. Traffic is reaching to which device? We telnet to 1.1. 1.1 is branch 1 router. So traffic is going to from 1.4 PC to router. Router will give reply. Agree?
Yeah.
Okay. This is first case. In second case, from same 1.4 PC, can I log into branch 2 router?
Yeah. If you allow it, it will access.
Yeah. Because initially between branch 1, branch 2, communication should be there. Let's say we already configured RIP protocol, routing protocol is enabled. Then you can access all services. Have allowed also. How branch 1, branch 2 connected? Via public network they are connected. Agree? Yes. Now tell me the process. From 1.4 PC, I'm trying to log into 2.1. It lost the password. You entered password. Now I'll get router 2. Again, router 2, enable password. So from which device traffic is generated?
From 1.4.
Now traffic is reaching to which device?
Branch to router.
Exactly right. From 1.4 to branch 2, right? So means traffic is complete this traffic, enter this traffic is generated from 1.2 to branch 1 router, branch 1 to public network to branch 2, and reply will come back. So means 1.4 user accessing branch 2 router via which network? Via public network.
But for
Means
this,
your passwords, your all passwords, your configuration, complete data is going via public network. Agree?
Yeah.
So what someone in the middle, if they capture your data traffic and you open that, then that people can come to know clearly what password you entered, what is the enable password, what is the secret password. After show running configuration, complete this branch to network plans inside what protocol is running, what public IP, what plans is configured, everything in be captured. You know why? Because we are using which service to remote login for login purpose, which service you used.
Telnet.
This telnet is not secure remote login protocol. Why it is not secure? Telnet will send entire data with clear text format, normal text format. Remember what is the differences between HTTP and HTTPS? Of course, these are websites like web applications. Like what is the differences? Basic difference, HTTP and HTTPS. HTTP is not secure. Why? HTTP will send complete data in what?
Open text.
Open, normal text, clear text format. HTTPS?
Encrypted.
Encrypted. So similarly, HTTP is similar to Telnet. Like what Telnet will do? Whatever we entered this complete data as it is, plain text format is sending. So even to capture the traffic and open that packet, we don't require much high-end tools. The basic tools are also good enough to capture the traffic and open it actually. Even free tools is enough actually. Then people can get to know complete plans, routing plans, everything. So Telnet is not secure remote login protocol. Don't use Telnet in real time. Have another protocol, which is SSH, secure shell, is also remote login. All network engineers used to remote login because we are sitting in an office, but a customer routers or customer devices are in client location. The client can be out of the city actually, or out of the state, or out of the country, but we are in office or we are in home. We are logging. We are public network. So don't use Telnet. Of course, Telnet is disabled actually in routers, but we have access for routers. You don't enable actually. So which is recommended? SSH, secure shell. Now tell me what is the difference between Telnet and SSH?
Clear text and encrypted.
Yeah, remote login protocols. Telnet is used to remote login on networking device for configuration purpose. Port number 23. Data is sent in clear text format between network device. It is not secure communication. Then which is secure communication? SSH is used for securely remote login on network device for configuration purpose. Port number 22. It provides data encryption between host and network device. But to configure SSH, your device iOS version minimum is 12.4 and later iOS version can be compatible. Like if a device iOS version is 12.123 does not support for SSH. Minimum is 12.4 and later iOS versions. So Cisco iOS should support encryption for enabling SSH. This is SSH configuration. IP domain name, a name can be used any name. Crypto key RSA generate. This is algorithm to encrypt your data. Login local, transport, input, SSH. Clear? Yeah. All good. So as per our plans schedule of today, internet related topics we have done successfully. What are the mandatory configurations to access internet? Default routing, interfaces, NAT on interfaces defining NAT configuration, can be static or it can be packed. And ACL rule. Remote login protocols, difference between SSH and Telnet. Tomorrow we'll continue with the VPN configurations, GRE VPN. Thank you. Have a good day.
Thank you.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thanks, everyone.